Hey everybody, I hope you're having an awesome day. I'm having a decent day, except I have this annoyance. I have this LG soundbar that is on my computer and I love the way it sounds. My computer speakers died a while ago and I just decided to use the soundbar, and it's great with one exception. That exception is that every few hours, no matter what the settings are, you can turn the auto power off or whatever, but no matter what the settings are, the thing will power itself down to save energy right in the middle of the day. So I would say it's about every 2 or 3 hours. Just, it doesn't matter what's going on. It doesn't matter if sound's being played through it. It just turns itself off. So rather than replacing it, I'm gonna try to use a couple bucks worth of parts and build a lazy hack. So let's take a look at some hardware. I've got some 1/6 watt 330 ohm resistors. 1,000 of them I probably paid $1 for. Let's see here. Let's grab the other Arduino's box. I know for a fact that doing this with an ATtiny is a little bit more complicated. So although it would probably be the smallest board that I could use, I'm going to go with a Nano. Let's see here. Some of these are pretty crusty. Let's see what we've got. I could use a Pro Micro or Pro Mini, but I have some other ideas for those, so I'm trying to bleed down some of my Nano collection. This looks like a Nano. Yeah, the old school mini USB. That one looks clean. All right, let's grab that. And let's get, right here. Get a infrared sending LED. So what we're gonna do is we are going to connect this LED through digital 3 on here to ground. Now I'm going to run it through a resistor, but what we're essentially going to do is take the long end of the LED, the anode, and we're going to put it to D3 if you're on an Uno or a Nano. Now if you're on a Mega, I believe it's pin 9, but I'm going to go D3 since I'm on an Uno or a Nano, and then I'm going to run the short leg, the cathode, through a resistor and back down to ground. Now I'm not trying to shoot this very far. In fact, it only needs to go about 1 inch or 2, so the resistor doesn't matter as much, or the size of the resistor doesn't matter as much, but I'm going to go 330 ohms, and that should be sufficient. So let's see what we come up with. Okay, so I wanted to keep this thing pretty compact, so I soldered the LED rather short and just got it all together there between ground and pin 3, and we're gonna pop the code on it and see how it works. So I made a video a few months ago about a universal infrared and 433 megahertz receiver, and I think it's a great project to have on hand. That's what I'm going to use to capture the codes from my remote. Now if you don't have one of these, any IR receiver will work. You can just hook it up to your Arduino, and super simple. Follow the directions in this video. The code is down here. But if you don't have all that hooked up, another thing you could do is go to the library. And so when you open up the Arduino IDE, you have examples, and as long as you have the IR receive library installed, you can come here to IR remote, it's called, and there are send demos and receive demos. And so what we're doing is we are firing up the project that we already built. And so I'm going to open up the serial monitor. Let me set the port. Port 36 is my universal receiver. I'm going to open up the serial monitor and bring this over here. I can snap that to the side. I can minimize this. I can snap this to the right. So we have the message that the receiver has booted, and all I have to do is point the remote at it, and I hit the up button, and we get the code for up, and I push it again, and we get the code for down. Now normally, especially when these are lower bit rates, I tend to use this bit of information, but in this situation I'm going to use this one. So I'm going to use the raw data. And you'll just have to kind of play around with it if you do something like this on yours, but I'm going to copy and paste that and put that information in a notepad so I have it available to me later. So the example code for this and all my video projects is right here on my Another Maker GitHub. You click that, you go to IR and RF for infrared and remote and radio frequency projects. Click on Soundbar Fixer and this is the sketch. It's pretty simple. What it does, it gives you some notes up here. You're going to need to install the IR remote library if you don't have it already. We're defining that the frequency is 38 kilohertz, which is for pretty much everything. We are assigning the raw data for the up button to this variable, the raw data to for down to this variable, and then we're including the remote, setting up the send. I just put out a little bit of serial data saying that it's booted, and then we're gonna go ahead, we're gonna send it for the up, we're gonna wait half a second, we're gonna send the down, and then we're gonna wait 30 minutes to do it all over again. Now when you're testing, you probably want to make this 5 seconds, but anyway, super simple. So as an initial test, you can see that I'm just pointing the device there, and it's doing every 5 seconds. That's not what I'm going to do in real life, but I just figured I'd show you that it is working, going up and down, and then keeping it at the volume that it was. So what we're going to do is we're going to plug this thing into the USB port that's already on the soundbar. Just so the unit isn't distracting, I have it sitting a couple of inches in front of the unit, down behind another monitor, and so it's just still doing its little 5-second demo right now. I'm going to put that out to probably 10 or 15 minutes. It'll bump it up and down every once in a while, but that's it. I hope this was helpful to you. I hope it gives you some ideas, and thanks for watching. Have a great day.